And I want to point this out because I'm going to come back to this quote at the bottom that I've paraphrased from Kraft Ericke in 1984. God wanted humans to become a spacefaring species. He would have given them a moon. And I want to sort of this presentation is to actually sort of give a brief summary of what was defined in LSSW 17. And one of these one of these issues was the highlighted the need for understanding if lunar resources are reserves and the types of data that are needed to do that. And I presented this data table during that first workshop. And as you can see, many of these data types would need to be taken via surface mobile assets. But there again, this is why we actually need international participation and commercial participation in such a coordinated resource evaluation campaign, because if you look at the top 10 most promising sites for polar volatiles on the moon, they cover an area greater than 6,000 square kilometers, as defined by the Brown et al. Icarus paper earlier this year. So a lot of real estate to cover. So the coordination is going to be key, and highlighting those areas that need to be investigated is also key. So what should be implemented in such a coordinated campaign? Well, again, what came out of LSSW 17 is the coordination of data gathering efforts from current and funded missions that are focused on lunar resources or could be focused on lunar resources. And a list was given, and I'll come back to that in a little bit. And then defining the data types and also the fidelity of data needed to derive useful products for future missions. And then developing lunar resource standards and evaluation metrics. And we're going to hear from Carlos towards the end of the session about a way forward with that. And then inclusion of partners in this effort. As I say, there's a lot of real estate to be covered just for polar volatiles. And we know that there are other resources on the moon that are potentially useful. And then defining a data policy or data policies. I mean, how are the data? Are they going to be? Is it going to be open source? Are they going to be data buys? So to bring in commercial providers to get the needed data. There are various ways to do this, and we need to be open to these various ways of data gathering, such that we can put together prospectivity maps in a way that is meaningful and quantitative. So leveraging from private industry is also going to be key, given the importance of this burgeoning lunar commercial industry that we see going on right now, and developing a list of high priority targets using existing orbital data sets to focus surface exploration. There was the idea of actually conducting a reserve report for the moon based upon current data, and then in doing so, then highlight those data needs in a bit more detail and a bit more quantification to that particular study. And then developing mission concepts that could be deducted from orbit at better resolution than current data sets. And a couple of were pointed out: neutron spectroscopy, spectrometry radar, maybe IR reflectance to look for surface deposits. So one way to begin the coordination is to look at the plethora of different missions that are either at the moon, on their way to the moon, or going to the moon, either in orbit or going to the surface. And you can see there are different countries and space agencies listed in the top part of this table, and then the commercial missions listed beneath that are going to the South Polar region. So this could be a way to start that international cooperation, because it's not just and there's no one country or one commercial company going to the South Pole at this time. So this is a way to start small and then grow things to a more integrated and coordinated surface campaign. So we could agree on data fidelity. We could define a common data policy, developing standards so the data sets from various missions can be directly compared and overlain. And this would be using the same agreed upon coordinate system for seamless integration of those data sets. Something that would seem initially trivial, but I'm led to believe that this is exceedingly important. And you can see that in doing so, we would start to address number 2, 3, 5 in the implementation plan from LSSW 17 on the previous slide. Expanding the coordination, getting better spatial resolution of neutron data at both poles. Um, so there are concepts out there, and I've cited the Lawrence et al. 2015 again, that says that, and this particular concept gives you hydrogen sensitivity less than 200 ppm and spatial at a spatial scale of about 5 kilometers, thus addressing number 8 on the LSSW 17 implementation plan. Once the surface locations are specified, the collaboration and cooperation developed by coordinating the current missions could develop the surface campaign to obtain the required data. We actually have something to iterate from by starting small and then coordinating something that missions that already exist or are scheduled. So coordination of a surface mission would address 4 and 6 from the LSSW 17 implementation plan. And as you can see from the diagram on the right, the data that we would get from exploring these polar volatile deposits at the surface with mobile surface assets would benefit multiple stakeholders. Um, it's it's uh, it's evident that we would get more than understanding the reserve potential of these particular deposits. We would get a lot of data that would help understand how the origin and evolution of these deposits, as well as the exploration potential for actually supporting human exploration and maybe even a cislunar economy based upon what we have learned from these particular missions. So we have a framework, we have a way that we can move forward with this, but again, there are other things rather than just missions and data, and whether or not we get science data that informs science, commerce, or exploration. And that is what we're going to be looking at as we go through this particular workshop. So my last slide shows the moon as an enabling asset. And I put this up here for a very good reason. Again, we have aspirations to go further afield beyond the Earth-Moon system. And again, in order to do so, we need to learn to live and work productively off planet. And again, the moon being in our own back garden, so to speak, is Kraft Ericke got it right, that we have the moon there. It becomes an enabling asset, not only for sending humans further afield and doing that and de-risking that particular endeavor, but also in terms of other things that would have direct benefit to humanity back on Earth. Initially through creation of jobs as these new space companies start to grow, and we're seeing that with the commercial lunar payload service providers and seeing their job growth as they are continuing to add jobs to their add people to their workforce. But there are other things that go beyond that, such as the rocket fuel that people have talked about. And in many ways, this used to be science fiction, but it is becoming science fact. So I'll leave it there